Hi class, let's take a look at example 1 part B. Now in example 1 part B, they're only asking for the critical value, and this is to construct an 80% confidence interval but for proportions. And just to clarify, when we're talking about proportions, your actual critical values are going to be these here. So technically, they're all going to be z-scores. Now, if it's a standard 90, 95, and 99, you may jump into and just evaluate those numbers. But in this particular case, it's not a typical C level, so we're gonna have to construct it. So here's the basic sketch. So the level of confidence is 80. So C is equal to 80%, and this means that this is 0.80. The values of alpha, well, that's the complement, and the values of C plus alpha has to equal to 1. So in this case, this is going to be 0.20, which means that each tail is going to have half of 0.20. So alpha divided by 2 is equal to 0.10. Now, in the construction, and once again, we're talking about proportions here, these would be C-scores. So technically, there's going to be a C on the left and a C on the right. This part of the middle is C, which in this case, it's accounting for 80%. And then the shaded region of the C-scores, this is going to be 0.10, which is equal to alpha divided by 2. And this is equal to 0.10, which is equal to alpha divided by 2. Which is going to translate to the following. The C-score that we're looking on the left, it's going to have 10% area to the left. So let me just run it. Give me just a second. To activate this one, well, we're just going to go to the distributions. And to find the C-score, it's going to be inverse norm. And we're inputting, because it's already standard normal, just the values of 0.10. And this is giving us negative 1.28. So the C-scores, the one on the left is equal to negative 1.28. I put the code here. Yeah, it's just 28. The one on the right is 1.28. And let me write it as the C-scores. The C-scores are C is equal to negative 1.28 and C is equal to 1.28. Now, for the critical value, we only report the positive. So you're going to notice that none of these give you the negatives. So you're only reporting the positive. That's so that it matches the formula from min to max. So it's part of the formula. So in this case, we would report that the critical value is Z is equal to 1.28. And I'll just mention to construct a C is equal to 80% CI for a proportion. So we're looking at a population proportion. And let me just put population in there. And the basic idea on these is that when you're finding a C-score or t-value, and in this case to construct a confidence interval, the current confidence interval, it's a proportion. Well, the critical value is only going to be reported as the positive C-score. And you may compare this to what we've done in the past. And in the past, we might have reported plus and minus as the critical values, but in this situation, because the critical value or the C-score is attached to a formula, this will be your formula, or technically the lower bound and the upper bound. We only report the positive. So all of these are going to be positives. In this particular problem, they're not asking us to construct the confidence interval. They just want the critical value. So the critical value, it's going to be positive 1.28. If they're asking for a sketch, we're expecting a bell-shaped curve where you label, well, both of the c-squares, actually both of the c values, or depending on the variable that we're using, the values of c and then the alphas. That's actually it for this one.